Hey, we had some questions about this one. I believe this is 4.59 from the homework, so I thought I'd just try to briefly kind of discuss this one. So this one is in chapter 4, but I think really it's sort of like many of our problems do. It draws a lot of stuff from vectors, and so that's probably the trickier part about this is kind of figuring out how to set up the picture and the angles and stuff. And the first thing is they sort of tell you about this idea of the law of reflection, which says that if something comes down on some surface and then shoots off from the surface, what you can do is like draw a little line here. This is like a 90-degree line, and basically whatever angle it came in relative to that line is going to be the same angle it leaves from. And so if you look here in this problem, so again there's like an incline, some ball comes in and bounces off, and so the kind of the key point is this little dotted line. You want to draw that again at 90 degrees to the surface. And so if I was to draw that, this isn't again perfect, but it's sort of our picture there. So that's our sort of dotted line, and so this angle on either side of here should be the same. And so what we want to do is figure out what that angle is. And so like we do a lot of times with situations like these, what we're going to do is use a similar triangle. And so if I draw this little dotted line here, hopefully you can see that this triangle that I'm making here with this line and then these two is similar to the big red one, are basically our incline. And so what you can figure out from there, and again there's always different ways to do it, but that's how I would do it. So this is the right angle, this is the right angle, and so this would be the 20 degrees. And so what that means is because it's relative to this line, which again is 90 degrees to that surface, this would be 20 degrees over here as well. And so then what we want to do is measure this relative to say that what we call like the horizontal. And so this would be like our horizontal, and so I want to find this angle here, which I'm going to call theta. And so what I do in this case is just sort of say, well, this whole sort of combination of things here is a right angle. Between the green line and this blue line over here, it's 90 degrees. And so if this is 20, 20, then 90 minus 40 would be 50. So this angle over here, which you'll often see referred to as the launch angle, is 50. And so this ball comes off with some velocity, some speed v0 at an angle of 50, right? And so you can make a little triangle with your initial pieces like we do often. And so if this is v0, which again, v0 is what you're looking for in this problem, we're saying this is 50, so it'll be v0 cosine 50 and v0 sine 50. So that's sort of one key point in this problem. Another piece that's maybe useful to look at is the distances. And so basically, when I look at this problem, I sort of said, well, this is my initial position for this object, and it's launched with some velocity at an angle. And then what it says is it lands down over here, and it tells you that you travel some distance 3 meters this way. Well, what you can also do is go over here and figure out your delta y, which would be this distance here that it traverses in the meantime. And so once again, we'll use some right triangle trigonometry here for this. And so this is again a problem where I believe this angle is 20, this side is 3 meters, and so for my delta y sort of piece over here, what I would do is I would do like something like a tangent of theta is equal to opposite over adjacent, and then the opposite side would be that delta y, and then the adjacent side would be that 3 meters. So then that delta y, and we'll be careful because we're using sort of a right angle, this would be like the absolute value of it, would be 3 meters times tangent of that angle, which I'll just go ahead and fill that in as the angle of 20. And so that gives you sort of the distance that it travels. And so this is delta because, again, we can define our distances, whatever. And so what I did is I called this for myself, I called that piece the origin, and then did our sort of typical xy axis. And so when you do that, then your delta y turns out to be negative 3m tangent 20. So those are the sort of pieces of information that you got to do a little bit of work to figure out for this one here. Okay, so hopefully that helps. Thanks a lot.